Okay, the last section in Unit 1 for pre-calculus is inverse functions. And this is lastly something you have seen before in Algebra 2. It is sometimes difficult when we are restricting the domain, as you'll see later in the notes, but we'll get to that. Let's go ahead and go over what inverse functions actually are. One anagram we can use to help us remember how we can write inverse functions. We can write them graphically, numerically, analytically, or by writing them. Sometimes people like to use this anagram. Graphically, you're just reflecting each point over the line y equals x. So you're basically flipping the domain and the range. You're switching them. So you can see that numerically, that if your first point, for example, is 0, -6, if you switch the domain and the range, you would rewrite that point as -6, 0. Analytically, we can look at it as a composition of functions. G of f of x and f of g of x should both equal x. And that the function g is denoted as the inverse of x. So, and we could also write it as two functions are inverses of one another if the domain and the range values for the relation are exchanged. Now, in order for the inverse to be a function and not a relation, it has to be one-to-one. So a function is one-to-one if any two different inputs never correspond to the same output. When the inverse of a function f is itself a function, then f is said to be one-to-one. So let me show you this diagram in the next page here. So we've got an example where you have the purple is the input and the output is the green. So this, for every input, there is exactly one output in this second function here. This is a function. However, for the first one that's not a function, this input has more than one output, so it's not a function. But in order for it to be one-to-one, every output has to have exactly one input, and every input has to have exactly one output. So back to the first page. And that example, by the way, if you're looking at the notes, that's not in your notes. I just put that up to explain that. All right, so another way to look at that, in purple here I wrote, it's got to pass the horizontal and the vertical line tests in order for the function and its inverse to both be functions. Okay, so find the inverse function of graph, table, or points. So if you've got ordered pairs, you're just switching the x and the y coordinates. In this example A, the inverse of this function is not a function because notice the first time we input 4, we get -2, and the second time we get +2. For B, when we switch the x coordinates and the y coordinates, again, the first time we input 6, we get 4, and 6, we get 6. So this inverse would not be a function. So now we are going to do that graphically. Find the inverse of a graph, table, or points. Okay. So we're going to go ahead and we are going to switch the x and the y coordinates and try to graph them. So you're going to be doing this in the practice in the U-Try a little bit lower, but we'll do these together. So these coordinates, I'll start with the first one here. The vertex is at 1, -4. So if that's at 1, -4, when let's see if I can draw a line. This will let's try that again. Here we go. Okay, so there's my y equals x. I'm reflecting these points over y equals x. This point at 1, -4 should be -4, 1 when I switch them. And you can see it's the same distance away on the other side of that line. All right, so let's go to the other ones. We've got 2, -3, and that should be -3, 2. And then we've got 3, 0, and that should be 0, 3. And let's go to the other side of our quadratic. We've got 0, -3, so that should be -3, 0. Starting to look right. And -1, 2, and let me erase that dot. -1, 2 should be 2, -1. Wait, that's not right. Sorry. -1, 0, right? Should be 0, -1. There we go. And then if I draw that, I've got an inverse, just switching the x and the y coordinates. You can go ahead and do that for D, but I'm going to make sure I finish this so I don't run out of time. So the vertical line test can be used to determine if the relation is a function. So the horizontal line test can be used to determine if the relation's inverse is actually a function. So for the first example, we see that the graph passes the vertical line test. So, but when I look at the horizontal line test, the inverse is not going to pass it. So the relation is a function, but the inverse is not. Okay, and here, okay, that's supposed to be a circle. Nice graph. Neither one. And are there any functions here? Well, it doesn't pass the vertical test, so this relation is not a function. But the inverse looks like it is. So you are going to do the 2 U tries, and then you're going to look at the answers. If you've got graph paper, use graph paper. All right, so here we go. So you don't have to worry about writing the equations. I just went ahead and did. But again, you're reflecting the points over the line y equals x. So that's just a great way to check yourself and just make sure that those, whatever points you have, are the same distance away from that line from both directions. Okay, and so is the inverse a function? We kind of just went over that. All right, so if you got questions, you can ask about that in class. So now we're going to move on to the tough part. So steps to finding the inverse analytically. Okay, so what we have to do is switch the x and the y, solve for y, and then we're going to verify. You cannot miss this part. You have to verify that the domain and the range have been switched. And that means you're going to plug in f of x into g of x, and you're going to plug in g of x into f of x, and they should, if they're inverses, they should undo each other, and they should both be x. And you have to do both, because on different occasions, you might get a negative x, you might get, depending on the domain, it gets a little tricky sometimes. So you have to check both. So let's go ahead and switch the x and the y. And again, you have seen this before in Algebra 2. It's just been a while. So now we're going to solve. And we'll get, okay. So I'm just going to rewrite this as 3y equals x plus 9. Now divide both sides by 3. That's a 9. So we get y equals x plus 9 over 3. Okay, so in order to verify that that answer is correct, I have to plug, this is our input and our output, we have to plug each one into each other and make sure they undo each other. So I'm going to start with 3x minus 9, and okay, here, and I'm going to plug that in right here, plus 9 over 3. Now I should get x, because 9 is 9 plus 9, those are going to cancel, right? And I'll get 3x over 3, which is x. Awesome. Now I have to plug x plus 9 over 3 into 3x minus 9, and notice I'm going to get x plus 9 minus 9. Yay, I'm getting x. So I have verified it. The hardest part is when you have to restrict the domain. So sometimes you'll get a problem where, and don't look at B, just we're working on A right now. You've got a quadratic. So the inverse is not a function. But it can be if we make it 1-to-1 and we restrict the domain. So like, the graph, we select one side of the graph so that when we reflect it, I'll just make that x, y. So when I reflect it over the line y equals x, it'll be a function. Okay, so we're just going to go ahead and start. So let me go ahead and write the equation. Y equals x squared, but I need this for x is greater than or equal to 0. Okay, now when I switch my x and my y, whoops, no equals. now y is greater than or equal to 0. Because I just switched the x and the y. So now I'm going to solve for y. So go ahead and take the square root of both sides. And I get square root of y squared is actually the absolute value of y. We're just going to go ahead and write y. And that equals the square root of x. So the inverse of x equals square root of x. All right, now let's go ahead and verify. So I'm going to plug in x squared okay, and now I'm going to plug in the square root of x. Now the square root of x times the square root of x is x, so we're good. Okay. I'll go ahead. I've written out the verification down here. If you want to take a look at it, do I have time? Yes. Okay, so let's go ahead and, so x here has got to be greater than or equal to 4, right? Because anything I put in below 4 is going to give me an error. I'm not going to be able to graph it. Okay, so just noted that. So let's see. All right. Now we'll go ahead and switch the x and the y. Solve for y. So I'm going to add 2 and then divide by 2. So that's just going to be x plus 2, and then when I divide by that 2, I get the square root of y minus 4, right? So now I have to square both sides. I'm solving for y. And you may have to pause this and look to see what I did. So the square root of y minus 4 squared is y minus 4. And that should equal x plus 2 over 2 quantity squared. Add 4 to both sides. Run out of room. So y equals x plus 2 over 2 squared. Ugh, I hate how messy this is. Plus 4. Okay, and then you would verify. So the inverse of x is right here. Okay, so I think that is enough. I'm looking to see if there's merit in this one. I've got 2 minutes. Okay, so go ahead and switch the x and the y. And I might run out of time. All right, I'm going to move the 2 over. And then I'm going to cube it, both sides, right? So that's the cube root of y plus 4 and then cubed. Okay, so when I cube this side on the right, I'm just going to end up with y plus 4. So that's x plus 2 cubed equals y plus 4. Subtract the 4 and I get y equals x plus 2 cubed minus 4. So that's, and you would substitute for y the inverse. The inverse of x equals x plus 2 cubed minus 4. And here's the verification. Take a look at it. All right, peace.